Hello and welcome everyone. Uh, so today is our 13th session, I guess, of the goated DSA grind, and today we will be continuing with the linked list topic that we have been discussing. And again, we have two more questions for today. Both are rated medium on lead code, and one is removing the nth node from the end of the list, and the other one is uh, copy list with random pointer. Okay, so this is it. So our today's agenda say would be to solve these two questions. The first one is removing nth node from the end. The second is yeah, copying a linked list with random pointer. Okay. So without much further ado, let's get started and let's look at the first question for the day. That is removing nth node from the end of the list. Copy the question there. Okay. So what this question says us is we are given a linked list, okay, a singly linked list, and we need to we need to remove the nth node from the end of the list, okay, from the end of the list. So here suppose it's 1, 2, 3, 4, 5. So the number of nodes that this particular linked list contains is 5, right? And we are given n is equals to 2. That means we need to remove, this would be the first element from the end, and this is the second element from the end. So we need to remove 4 and excuse me add and then point 3 directly to 5, okay, and not to 4. So this is how we'll be removing uh, 4 from here. So how can we do this? Let's first look at the brute force algorithm, the brute force approach. So in this, if you remember, we have previously solved one question in the previous session that was in that we had stored the list nodes, the pointers, inside a vector. In order to access the first and the last at the same time, we had it inside a vector. Okay, so this is something we can do here also, that we form an array of these particular list nodes, okay, of list nodes, rather list node pointers. And what do? We then see what this position is. So in arrays we have 0, 1, 2, 3, right? 0, 1, 2, 3, and 4, and we are given 2, that is 2 from the end. So which index that we have to remove, that is third, right? So 4 minus 2 plus 1 is the index that we'll have to remove. In general terms, it would be n minus n, where n is the size of the array, minus n that we are given, plus 1, because of course the indexing starts from 0, but we need to take yeah, plus 1, the third wala value. Okay, so what we can do is we can remove this particular index there from the array and then copy back the elements of the array in a linked list. Okay, so make the linked list again, make a linked list from the array. So this is one approach, कि हमने क्या करा कि सारा नोड्स को पकड़ करके एक एरे में डाल दिया, एंड देन वी कैलकुलेटेड n माइनस एन प्लस वन, उस वाले पॉइंट को हटाकर बाकी सबको शिफ्ट करना पड़ेगा या जो भी, तो उसके वो करने के बाद as we do removal in an array, we need to remove the list node pointer and then make this, and then you can make a linked list from the given array. Okay, so that is a brute force approach. which will of course require what time? One will require we will require to have all the nodes inside the list. So all the nodes inside the list will be taking order of n time. Then the removal takes somewhere around order of n square time. The removal of 4, so you need to um, pull 5 to the front in order to remove 4. So that will take somewhere around order of n square. And then we need to make a linked list again from the array that again takes order of n. So overall the time complexity here would be considered as order of n square. Okay. So that is the brute force algorithm. Now let's now look at the better approach that we can have. Okay. So one approach is using pointers. Okay. 2 pointers. So now if you carefully see, you'll be able to get how we can use 2 pointers, right? Let's write it here only. How we can use 2 pointers is, suppose we are in this particular linked list, okay, right? And our head is this particular point. So what we can do, we can set up a pointer that currently points here, okay, and then we can increment this pointer to go and point till this thing, and then we will also count key what is the total number of nodes, okay, total number of nodes. Because without doing this, without moving this current pointer from here to here, we won't be able to count कि एक लिस्ट नोड में कितना number of nodes है, right? So we do this just to get a count. Okay. Now once we have a count, suppose in this case it's 1, 2, 3, 4, 5. So in this case we have a count 5. Now we have another pointer again starting from this pointer point. Let's name it ACUR. That's another current. Okay, anything. And then we move this. So we have to move this to this particular position. Okay, not this actually, this particular position. How? See, we are given n is equals to 2. So what is 5 minus 2? That gives us 3. And we need plus 1, right? To remove this particular position. This is 4, right? This is 4. So what is the position that has to be removed? 5 minus 2 plus 1. That is n minus small n plus 1. This is the position to be removed. But what I am saying is, we do not go till this particular position and we stop at this position. Okay. So what do we need? We need n minus n. ये प्लस वन को हटा रहे हैं, ठीक है, क्योंकि हमें यहाँ पे रुक जाना है थर्ड वाले पे. Because it's very obvious what are we gonna do next. Suppose we need to remove this particular thing from here. Okay, this particular thing from here. So what are we gonna do? This is the third index if you consider from 1. So we will stop at the second point. So now our A current is here. And what are we going to do is, we will directly make A current का जो next है, that is this pointer, directly point to this thing. Okay. So what do we write here? ACUR next is equals to ACUR next. What this means is, this ka next is this and next is this. So you are directly positioning A current ka jo next element hai and making it equals to this particular thing. Okay. So this is how a 2 pointer approach would work here. Counting the capital N, moving on uh, to remove n minus n. ठीक है. अगर जीरोथ इंडेक्स लेंगे तो वही अगेन वो प्लस वन माइनस वन हम लोग देखेंगे कोड करते समय. बट अगर वन इंडेक्स से ले रहे हो तो यही होगा. ठीक है. So let's see how do we code this particular thing here. Okay. So as I told you, let's have a capital N that is initialized to 0 and a list node pointer current that currently points to head. अभी हमें क्या करना है? एक काउंट रखना है जो कि हमारा n है खुद ही है. or we write while current is not equals to null ptr. What are we gonna do? Of course the count को आगे बढ़ाएंगे और current को भी, this should be a single R, current is equals to current का next. Right? If you can tell in chat, then that would also be good. So this is how are we gonna count the number of elements, count the number of nodes, count number of nodes. Now once we have counted the number of nodes, what is the node that we need to remove? So we write int remove this rem equals to n minus n, right? Okay. As I wrote this thing here. Now if one thing is obvious, that if remove is equals to 0, मतलब we have to remove the 0th वाला index, तो हम लोग सीधा रिटर्न कर सकते हैं head का next, that will be null. और rather not null, मतलब मान लो हमें 1 हटाना है, तो we directly give 2 out here. If this is not the case, then what are we gonna do? We again point this current to head, and now we are gonna move this current up to the position. Which position? If we have to remove 4, we move it till the third position, right? So for that we can have a loop that can be a while loop, or this loop, capital N minus 1, since we have already counted this I plus plus. So if our I plus 1 is equals to the removal wala, removal wala index, then we are going to do certain things. What are those things? We can directly make current का जो next है, that to be equal to current next next, right? And once we are done with that, we can directly break. Okay, and in this case we will return the head that was there. But if this is not the case, then we need to move the current to the next point, right? So current is equals to current's next element. Okay, and I guess we are done in this. Okay, what are we doing? We are counting the number of nodes, and this is just a checker. If the removal is 0th element only, then we just give heads ka next value, and this is where we assign another pointer that goes up to this I वैल्यू यहाँ पे क्या होगा, n-1, जो हम वहां पे बोल रहे थे n-1 पे ही रुकेगा, ठीक है? Because we are checking if n-n plus 1 is equals to them, right? Plus 1 is equals to them, so this is equals to the I value, or rather let's write I is equals to n plus minus 1, ठीक है? अगर ऐसा कुछ केस होता है, so we are directly making currents next is equals to current का next, ठीक है? Okay, so it shows that it works here. Let's see if it gets submitted. Yeah, cool. So this is it. Now this is one approach, and now there is one more approach that we can follow. This we are having two passes, right? Actually, what we are doing here is we are having two pointers, but we are having two passes also. What are those two passes? First of all, we are counting. First of all, we are counting, and then we are initializing another pointer to head, and then we are moving up to that particular index. So we are moving up to that particular index, right? So these are the two passes or the traversals that we are doing. We can also have this in a single traversal, that we'll check. But first, let's just copy and paste this particular code here. Get me full screen. Where is it getting pasted? Mhm. One sec, one sec. Fine. So what is the time complexity in this case? These all, of course, will take order of 1. Now this takes order of n, capital N, where of course we, as we discussed, n was the size of array. Okay, n is the, or rather not size, but let's write number of nodes in the linked list in list. Okay, so that is the number of nodes in the list, and that is the amount or number of times this particular while loop runs. Okay, now we calculate rem, that is n minus n. So these all of course are running for order of 1. Okay, just one checker element and stuff. So these do not majorly contribute to the time complexity, but this particular things runs up to how many times? N minus 1, as I have written it here, right? So overall, if you look at the time complexity, you can correctly guess that it will be order of n, where n is of course the size of the array. And what is the space complexity? Are we creating any external spaces or any extra spaces? No, we are just assigning two pointers to the head value. So we are having a constant space. So how do we define or rather write a constant space? That is order of 1. Okay. So this is what we are doing in this particular thing. Now what we can have is something called a single pass. You know how we are doing that? It is key in a particular linked list. ऐसा कुछ हो मानो, तो हमें जो n का वैल्यू दिया हुआ है ना, लेट्स से n इज इक्वल्स टू 2 और रादर 1, ठीक है? तो n का वैल्यू जब तक है तब तक हम लोग क्या करेंगे, करंट को मूव करा देंगे. मतलब मान लो कि यहाँ पे करंट है, the current pointer is pointing to this particular thing. Okay, so what are we trying to do is move the current pointer until and unless this particular value goes to 0. So we move the current pointer here and this value comes down to 0. Okay, now once it comes down to 0, we are gonna move the null pointer how many times? While this right is not equals to, I mean, see, if n is equals to 1, what is the point that we have to remove? This. Okay, I mean, this is the node that we'll have to remove, right? So now move current to this particular position and now move left also, the left pointer, and now this is the current. Okay, just listen, this is quite obvious. We are moving current until and unless current is null pointer. Okay, so current goes here, and as we are moving current we are also moving left. Okay, so suppose current यहाँ पे जाएगा, जब जब C यहाँ होगा तो L यहाँ पे होगा, जब C यहाँ होगा L यहाँ पे होगा, एंड यहाँ पे होके जब C यहाँ पे आएगा तो लूप स्टॉप्स एंड we do not move L, so we have L at the correct position. Okay, so this is how we are solving the problem in a single pass. So this approach is called a single pass approach. If you get what I say, मतलब कि अगर ऐसा कुछ है, अभी के लिए एक एरे ही ले लो या कुछ भी ले लो, ठीक है, ऐसा कुछ है. अभी मान के चल कि तुम्हारा करंट यहाँ पे फिक्स है और लेफ्ट यहाँ पे फिक्स है. तो जब जब तुम करंट बढ़ाओगे और साथ के साथ तुम लेफ्ट भी बढ़ाओगे, तो व्हाट विल बी द नंबर ऑफ, व्हाट इज द नंबर बाय विच लेफ्ट विल बी लैगिंग द एंड. मतलब यहाँ से अगर वो इतना इतना तक के लिए छूट रहा हो करंट से, 3 बॉक्सेस, तो जब करंट एंड पे आ जाएगा तो लेफ्ट वाला भी एक्चुअली पीछे साइड से 3 बॉक्सेस ही छोड़ेगा ना. आई मीन दिस विल बी लेफ्ट आउट, दिस विल बी लेफ्ट आउट, दिस विल बी लेफ्ट आउट, राइट. This is the concept. Once you reach current in that particular position, now move both together and then move. You do the same thing. जो left वाला part है उसके next को left के next of next बना देना है. And that's it. Okay. Make left का next element equals to left के next का next. ठीक है. That is what we are gonna code here. And we will do this using a dummy pointer. Okay. How a dummy pointer will be using बताते हैं. It is कि एक यहाँ पे मान के चलो कि यहाँ पे एक डमी है, ठीक है, और इसका ये वाला पॉइंट कर रहा है इसको. दिस लेट्स से दिस इज अ लिंक्ड लिस्ट. ओके, दिस इज अ लिंक्ड लिस्ट, अ सिंगली लिंक्ड लिस्ट, ठीक है, एंड दिस पॉइंट्स टू फाइन. नाउ दिस इज अ डमी पॉइंटर or rather dummy node. Let's name it dumb, and a random pointer is pointing to this particular thing. Okay, this is how we are gonna uh, do this. So first of all, list node pointer dummy is equals to what dummy will be. You need to create a new list node, according to this particular thing that is written out here. So we are creating a new list node and initializing it to any value से 0, and उसका next जो है वो head को point करना चाहिए, ठीक है. तब तो dummy बन जाएगा एक तो, और वो head को point कर लेगा. अभी हमने left assign करना है जो left position पर है, और एक right जो कि हमारा current था इस condition में. Okay, we can assign left and right better. So let's assign left, that is currently pointing to dummy, and right. Now right points to head, right doesn't point to dummy. ठीक है, लिस्ट लेफ्ट वाले को पीछे ही रहना है एक तो, तभी तो मतलब साथ के साथ आगे बढ़ाना होगा ना दोनों को वापस से. एक्चुअली इंस्टेड ऑफ व्हाट वी आर डूइंग इज, ये 3 का गैप चाहिए तो तुमको लेफ्ट यहाँ पे होना चाहिए, ये वाला पॉइंट पे लेफ्ट होगा, ठीक है. तो यहाँ पे जैसे 3 का गैप है, यहाँ पे एक डमी वेरिएबल ले लो, और एक्चुअली लेफ्ट यहाँ से स्टार्ट होता है, ठीक है, और साथ के साथ ये करंट के साथ साथ जाता है. तो जब यहाँ पे 3 गैप होगा, तब व्हेन यू फाइनली मूव करंट 1 2 3 4 positions, so left will move 1 2 3 and 4th position here, ठीक है. ये कर सकते हैं हम लोग. तो हमने राइट असाइन कर दिया, दैट इज हेड. नाउ वाइल you have n that is not equals to 0, what you can do is n माइनस माइनस तो करेंगे क्योंकि हर इटरेशन पे हम एक n घटाते जाएंगे, और राइट is equals to राइट के नेक्स्ट. In this case what we are doing is moving the right pointer unless and until हमारा n 0 हो जाए, ठीक है. अब now once this is done, what are we gonna do, right का next, जब तक कि null pointer ना हो, और rather right ही लेते हैं, right का next लेने की जरूरत नहीं है, हम लोग डमी लेके चल रहे हैं. ये जब तक ना हो तुम right को भी आगे करो, right is equals to right next, and you do the same with left also. Okay, so left is equals to left of next. Now once these are done, what I told was left next is to be made as left next of next. Okay, now once we are done with it, what are we going to return? See, हमारा अभी क्या है कि हमें वापस से हेड ही रिटर्न करना है, विच इज डमी का नेक्स्ट. तो हम लोग यहाँ पे डमी नेक्स्ट रिटर्न कर देते हैं, जो डमी था उसका नेक्स्ट, दैट इज हेड. ओके, fine. List node pointer left is at dummy, list node pointer right is at head. So now while n right is right next goes up till n is not equals to 0. Okay, and then we move it together. Once we are done, we move left next is equal to left next. Okay, return dummy next. Let's see if it works. Yeah, submitted. Yes. Okay. So this is another way we can. This is more optimal because we are not running it, running two loops at once. Okay. तो ये एक ही साथ में काम हो जा रहा है, मतलब एक ही इटरेशन ले रहा है ना, दो बार तो हम लोग चल नहीं रहे। राइट तो जा रहा है साथ के साथ लेफ्ट को भी लेके जा रहा है। ओके। एंड अगेन इसका वेरी ऑब्वियस आंसर दैट आवर टाइम कॉम्प्लेक्सिटी इज ऑर्डर ऑफ n ओनली। If given the we have to remove the last index, so it will go till order of n only, right? And space complexity as usual was order of one because we are not using any extra spaces. Okay, just a dummy node, so that counts as constant space. Cool. So this is one thing, uh, one approach that we are learning in this particular problem. Okay, so we are done with this problem, removing the nth node from the end of the list. Now moving on to the next point problem, that is copying a linked list with random pointers. Let's get the question down here. This quite a big question. Let's see if we can get the whole of it. Hmm. I hope this is visible. If not, you can zoom in. Okay, cool. It says a linked list of length n given such that each node contains an additional random pointer. Cool. Random pointer which could point to any node in the list or null. Okay. In short, if I tell what this question tells us, see, let's read the question once. Okay, construct a deep copy. So what one thing important we saw was deep copy, this thing of the list. The deep copy should consist of exactly n brand new nodes. That's what deep copy is. Okay. So deep copy is creating new nodes. That is exactly same as the older nodes. Okay. That is exactly same as old nodes. Okay, that is called deep copy. Even if you have read OOPS, then we have a concept of shallow copy and deep copy. So shallow copy is something that points to that particular pointer. Okay, we are not creating a new node. Okay, so if the node is existing, and a head or any kind of a pointer is pointing this particular position, if you are copying the this and this pointer points to this particular thing only, so that is something called as a shallow copy. Okay, but here what we need to create is a deep copy. And deep copy means you are creating the whole of the object or a node, anything, a new object or a node that is exactly the same as the previous one, and where each node has its value set to the value of this corresponding original node, of course. Both the next and random pointer of the new nodes should point to the new nodes in the copied list such that the pointers in the original list and the copied list represent the same list state. मतलब जैसा पहले था हमने सिर्फ कॉपी करके एक नया बना देना है और कुछ नहीं करना इसमें, ठीक है? None of the pointers in the new list should point to the nodes in the original list. What this says is if this is the original list, ठीक है, तो तुम एक ऐसा नोड नहीं क्रिएट कर सकते जिसका नेक्स्ट पॉइंटर यहाँ पे जाके पॉइंट कर दे. This is not allowed. So that is what it means. What you have to create is यहाँ पे भी रैंडम जो पॉइंटर होगा वो इसके पास ही कुछ ऐसा होगा जो इसका डुप्लीकेट होगा बस, ठीक है? बट तुम इसको ले जाकर यहाँ पॉइंट नहीं करा सकते. That's what it is saying. Okay, let's keep the board clean. Now, for example, if there are two nodes x and y in the origin, then that's it. X dot random is y, so small x dot random is should also be y. Okay, value is represented as val. Now random index is random underscore index and so on and so forth stuffs. Okay, let's zoom in a bit here and check. What do we have here? So see, we have particular nodes. Okay, we have these in this format, right? And now writing values and moving next pointer is quite obvious. ठीक है, इसका value 7 होगा और इसका next pointer यहीं पे point करेगा, ठीक है? ये वाला जो next point है, ये इसको यहीं पे point करेगा, ये वाला यहाँ पे ही point करेगा, ये वाला यहाँ पे ही point करेगा. This is quite obvious. दिक्कत तब है जब random एक pointer आता है. Because see, random pointer can point जो भी हमारा let's write it here कि जो random pointer है ना, this random pointer, it can point to any node or null value. तो समझ रहे हो, ये 7 हम लोग अगर कॉपी करते हैं, मान लो पहले हमने 7 बनाया, ये सारा नहीं है, लेट्स से कि ये है ही नहीं. अम, हाँ ठीक है. तो अभी हम लोग अगर कॉपी करते हुए में हमने रैंडम को असाइन करना है, तो कहाँ असाइन करेंगे? इन दिस केस रैंडम इज पॉइंटिंग टू नल, बट वी हैवंट इवन क्रिएटेड नल राइट नाउ. ठीक है, तो इसको कहाँ पे असाइन करेंगे ये पता ही नहीं है हमें. ठीक है, एंड इन दिस केस इफ 13 points to 7, so that's okay if you somehow point it backwards to this particular 7. But if there is 11 pointing to 1, so if you have created a node for 11, now how will you place the random pointer if you haven't created one yet, right? तुम 1 यहाँ जब create करोगे तभी ले जाकर डाल पाओगे. So this is what is a challenge in this particular case. Okay, we won't be able to go back further. Let's remove this and let's see how are we going to do this. So first of all, what we can do here is we will somehow need to know that where our random pointer is gonna go. Okay, somehow need to know how and where we'll be placing our random pointer. So how can we get that? If you think by the original list that we have, we know that okay, this is the random pointer and this is particularly going to null. Okay, so if we store this somehow, so we will know कि 13 का जो random pointer है उसको उठाकर भैया हमें 7 पे डाल देना है. That's it. Okay, 11, whatever the random pointer that belongs to 11 should point to 1. Okay, so this can be done if we store it already, like if we know while creating the nodes. So first of all, what we are going to do is we are going to just create nodes. Okay, and we are not connecting anything, we are just creating nodes. So suppose these are the nodes that we have created. Okay, one and a null node, of course. Now what we are going to do is we are going to connect the next pointers that is there. Okay, जो भी हमारा next है पहले उसको connect करते हुए चलेंगे. ये वाला तो ठीक है, ये रहेगा, ये वाला ये रहेगा. इसको एक loop में लगाकर of course iteratively we will connect this. Okay, now for the random pointer what we can do is if you have guessed it, we can have, yeah, hello Devanshu bhaiya, uh, sorry if I saw the chat late. Hi. Okay, so we are then gonna connect this random pointer and we know this should be null. So we will be storing it in a hash map. Now what this particular map will have, if you can guess, this particular map should have a node pointer to node pointer kind of a state. Okay. And what are we mapping? We are mapping this particular node with this particular node. ठीक है, तब हमें लास्ट में जब हमारा सारा नोड्स बन के रेडी हो जाएगा, तब हमें पता होगा कि जब हम कनेक्ट करेंगे तो ये वाला रैंडम को कहाँ पे कनेक्ट करना है, ये वाला रैंडम को निर्जा करके नल पे कनेक्ट करना है. ये कौन बताएगा? ये this the key will say us. Okay, the key of this map, if this is m of mp rather, so what can we say is mp of if this original node, if you call it something, let's say if you point current here, okay, if this is visible or not, I don't know. Darker would be color would be visible. So say if you point current in this particular thing here, so you can say map of current is where the random pointer should point to. इसका random dot random. Okay. इसका जो random होगा और इसका जो random होगा, let's say copy बोलते हैं इसको, चलो copy. So copy का random is equals to इसका जो पहले वाले मैपिंग में जो रैंडम है वो, ठीक है, तभी तो हमारा रैंडम्स मैच करेगा, राइट? इसका इसका जो रैंडम था, मैप एट द दैट पर्टिकुलर थिंग, करंट का रैंडम, rather you need to write it like this, nodes random, so this should be at one in a single box, current का random, ठीक है? तो ये वाला वैल्यू तो हमारा जो है, ये जो आंसर देगा, ये इसका जो कुछ भी वैल्यू आएगा वो कॉपी एरे में ही आएगा, कॉपी लिस्ट में ही आएगा। इफ यू आर गेटिंग माय पॉइंट, की वैल्यू पेयर होता है ना, जो की है दैट बिलोंग्स टू आवर ओरिजिनल लिस्ट, ठीक है, लेकिन इसका जो भी वैल्यूज आएगा दैट इज बिलोंगिंग टू आवर न्यू कॉपीड लिस्ट, ठीक है, ये कॉपी पे है, तो इसका जितना भी वैल्यूज आता है वो सारा कॉपी पे है, ठीक है? तो कॉपी का रैंडम जो होगा वो इसका रैंडम होगा, और कॉपी का जो नेक्स्ट होगा, नेक्स्ट, वो नथिंग बट वो जो मैप हमने बना के रखा है करेंट, उसका भी नेक्स्ट होगा, ठीक है? और हम लोग करंट और कॉपी दोनों को आगे कर देंगे, ठीक है? ओके, so let's see how do we do this in code. Let's go through this, what this is. Definition for a node. Okay, so instead of list node we are using nodes here. We have values, we have a next pointer and a random pointer, that's quite obvious. Okay, so let's start by using an unordered map here in this case. Okay, unordered map, and as I told you, that should be node pointer to node pointer, right? Call it anything, mp. Okay, and then you just make mp का जो null वाला वैल्यू है उसको null बना देते हैं, क्योंकि null यूज करना पड़ेगा अपने को, ठीक है? ये किया, अभी क्या करना है, सारा वैल्यूज को उस पर डालते हैं, ठीक है? सो जो हमारा नोड पॉइंटर करंट है, मतलब करंट बनाते हैं जो कि हेड को पॉइंट करेगा। नाउ व्हाइल करंट इज नॉट इक्वल्स टू null pointer, what are we gonna do? We are creating a node pointer copy, जो एक नया ये बनाएगा, ठीक है, एक नया नोड बनाएगा। यहाँ पे हम जो कॉपी का नोड बना रहे हैं, सो न्यू नोड कैसे बनेगा, इसको न्यू, और ये फिर नोड नोड क्लास है ना, सो एक ऑब्जेक्ट बना देते हैं न्यू नोड का, ठीक है? अभी इसका वैल्यू क्या होगा, वी आर पासिंग द वैल्यू, सो द करंट इज वो ओरिजिनल वाले का। तो अगर हम यहाँ पे लिख दें कि करंट का जो वैल्यू है, इफ यू कैन सी दिस इज वैल, ओके, सो करंट का जो वैल्यू है उसको हम न्यू नोड का वैल्यू कर दें, सो विल बी क्रिएटिंग अ न्यू नोड, ठीक है? ऐसे करके हम सारा नोड्स बनाते हैं पहले, as I told you, we are creating the all the nodes first, then we will be linking, right? बट हमने नोड तो बना लिया, अभी साथ के साथ हमने मैप भी करते जाते हैं। तो एमपी का जो करंट शुड बी इक्वल्स टू कॉपी, ठीक है? की है हमारा करंट वो पुराने वाले में से, और नया वैल्यू जो बनाया कॉपी, उसके साथ मैप करते गया है, ठीक है? और अभी तो सिर्फ सिंपल करंट इज इक्वल्स टू करंट का नेक्स्ट। So there are two things that we are doing here, that is creating nodes and mapping it Mapping. How are we mapping original to? Fine. Once we are done with that, now we'll be linking. ठीक है, अभी यहाँ पे लिंक करेंगे. तो लिंक के लिए क्या बोला कि हमारा कॉपी तो यहाँ पे है और करंट यहाँ पे है. वापस अगर हम लोग करंट को हेड कर दे, ठीक है, करंट इज इक्वल्स टू हेड, तो अभी वापस से हमारा करंट जो है वो हेड को पॉइंट करने लगा. ठीक है, नाउ अगेन वील हैव व्हाइल करंट इज नॉट इक्वल्स टू नल पीटीआर. ठीक है, अभी जब तक ये नहीं होता तो हमारा क्या करना है, जो कॉपी है, वी आर मेकिंग अ पॉइंटर कॉपी के लिए. ठीक है, मैप ऑफ करंट. अगर तुम समझ रहे हो कि एक हमने नोड पॉइंटर कॉपी बनाया विच विच इज नथिंग बट मैप ऑफ करंट. ठीक है, मतलब कि इसके लिए अगर करंट यहाँ पे है तो स्टार्टिंग पोजीशन के लिए बनाया पहले. ठीक है, इसके लिए हमने ये बना के रखा. ठीक है, अभी क्या करना है, सीधा कॉपी का जो नेक्स्ट है दैट विल बी नथिंग बट मैप करंट का नेक्स्ट, है ना, और कॉपी का रैंडम जो है दैट इज नथिंग बट मैपिंग द करंट. सी, राइट, एंड देन वी मूव करंट हियर. एक इटरेशन के बाद क्या होगा कि करंट यहाँ पे चला जाएगा ऑफ कोर्स. तो अब जब यहाँ पे करंट आएगा तो हमने ये क्रिएट किया होगा कॉपी में. ठीक है, जस्ट वी आर डूइंग नथिंग बट कॉपी का जो नेक्स्ट है दैट इज करंट का नेक्स्ट. बट करंट का नेक्स्ट कहाँ स्टोर्ड है, वो मैप के अंदर. सो वी आर जस्ट यूजिंग दिस थिंग. ठीक है, दिस पर्टिकुलर थिंग. और कॉपी का रैंडम इज मैप्स रैंडम, राइट, एंड करंट इज इक्वल टू cool. What are we going to return? What are we going to return? If you can see here, we have to return a node pointer. So return जो मैप हम बनाए थे उसका करंट रिटर्न कर देते हैं. होगा इससे, चेक. नॉट एक्चुअली नॉट करंट बट हेड स्टार्ट, क्योंकि हमें क्या रिटर्न करना है, ये वाला चीज, ये पूरा रिटर्न करना है. इसका इसका पॉइंटर है, समथिंग पॉइंटर दैट पॉइंट्स टू दिस पर्टिकुलर थिंग. तो इसको रिटर्न करना है हमने को. इफ यू ब्रेक डाउन द कोड दैट विल बी वेरी इजी फॉर यू. इसका पॉइंटर को हमने को रिटर्न करना है. ठीक है, दिस थिंग वी हैव टू रिटर्न. सो व्हाट इज दिस पॉइंटर, वेयर दिस पॉइंटर इज पॉइंटिंग. इसका जो करंट वाला वैल्यू है, सी मैप का हेड is nothing but this, right? You are mapping this pointer with this particular pointer, है ना. तो मैप का हेड अगर रिटर्न करेंगे तो वो पर्टिकुलरली हम ये रिटर्न कर रहे होंगे. So this is what we have to return. Let's see if it works. See, okay. Perfect. See the format is uh, okay. You can just take a look at the format yourself. It's nothing but 7 and the random pointer. These are the random pointers that are pointing. 13 points to 0, and the rest is quite obvious. It's not writing 7 pointing to 13 because of course ये ऊपर वाला जो नेक्स्ट है वो तो of course सिंगली लिंक लिस्ट टाइप आगे जा रहा है. So it's just writing 7 के साथ null है, 13 के साथ 0 है, 11 के साथ 4 है, and so on and so forth. What do you have to return? You need to return this exact same thing. Okay, your created nodes, the deep copy that you're creating should return the exact same thing. So let's see if it works. If we submit it, yeah, it does. Okay. Time complexity. Can there be a better time complexity in this? Okay, we'll see that. Okay, let's first copy the code there. Uh, I don't know where this goes. Why is it pasting? Fine. So if you see the time complexity, these are of course taking order of one time, just declaring you, just declaring that. Now this particular thing will run for how long? Until and unless the current points to the null pointer. So this runs for the number of nodes that you have in the linked list, okay? And now then we are linking again. So again, this runs for order of n. So overall, what we are doing is uh, running it twice actually. And if you note the time complexity, that is order of n. The space complexity here will also be order of n because we are storing it in the map, right? Map is requiring some space. तो हमने जो मैप पे ऐसे की वैल्यू को एक में करके लिया था, तो ये कितना दूर तक लोगे तुम? जितना नंबर ऑफ इनपुट्स है उतना मैप के अंदर भी तो की और वैल्यू रहना चाहिए. So that's why we are having order of n space complexity. I don't know whether a better solution exists because let's check what they have done. You should check things that are present here. If solutions are open, these are closed. These are closed. Fine. What they have done is um, creating a temporary node that points to head. Temp is new node temp value. Okay, we'll have to see if there is a better solution. You can check it by yourself also. Just do one thing. I'm pasting it there. So if you need to check, just go through it once. Is it even visible? No, it's not. Fine. Here also they are taking map only, original and the copy. But I don't know why are they taking integers in between. Mapping something to an integer and then integer to back to that. So they could have directly took node pointer. Ah, they are creating a new node. That's okay. That's copying it. This is the exact same thing. I don't know why it's taking a lesser time. This is order of n only, my complexity. Yeah, I don't know, maybe. But the approach is this only, that we need to have a mapping or somehow we need to, store things inside this. Oh, they are running here. They what he has done is ran two other loops. So once they are connecting next वाला चीज और रैंडम के लिए एक अलग से वापस से लूप चला दिया उसका ऊपर वाले का रैंडम और नीचे वाले का रैंडम मैच कराने के लिए. If temp of next is nil, temp of next. Okay, anyways. So I guess we are done then. Pasted it here. Yeah. Okay, so that's it for now. That's it for today. And these all will be shared with you. Okay, then we'll meet you in the next class. That would be on 31st, I guess. Yes, 31st. Okay. Till then, see you. Bye bye. Keep grinding. Bye bye.